This question is quite tricky, I think. Now, the work solutions did in very different ways of how I did it. I'm just going to talk about them briefly, and then I'm going to show you how I did it. It really helps to understand my method if you have covered roots of polynomials and further maths. I know that might not be the case, but it should still make sense, I think. So in the work solutions, they basically have it as a hidden quadratic and solve for x squared. And then that means if they've got plus or minus cos theta, plus or minus cos beta, if they square it, then they've got the values of cos squared and theta and cos squared beta, from which they can do 1 minus that to get sine squared. And then they get these two equations, and they can bring it back together to create a quartic. Pretty messy with all these surds, but it does give the answer. Okay, I'm not going to go into more to that, but do have a look and make sure you understand it, because it's important to understand more than one method anyway. So I kind of did the approach, but I didn't bother finding the roots at any point, which is kind of the idea when you're dealing with roots of polynomials. Um, so this is x by both of these, which means x squared is going to be cos squared theta or cos squared beta. Let me introduce a new unknown. I'm going to call it w, and that is my plus or minus sine theta or plus or minus sine beta. But then w squared is going to be sine squared theta or sine squared beta. And I can relate these together because sine squared plus cos squared is identical to 1. So therefore, x squared is going to equal 1 minus w squared. That's the relationship between the two. And I want to create an equation, essentially, which has roots of sine plus or minus sine theta plus or minus sine beta. And that's what one involving w will have. So all I need to do is replace all of my x's in this equation by w. I've already got the x squared, I just need to work out x to the 4. I just want to say this one more time because this is like an absolute crucial point. So we've got x as having 4 roots. So x squared is like both of these equations. W is then these 4 roots. I squared that to get it sine squared. I could then link x squared and w squared together. And I want an equation for in terms of w, because if I get a quartic in terms of w, then that will necessarily have these roots here. But all I need to then do is substitute in for x. So x squared is 1 minus w squared. X to the 4 is going to be that squared. So w to the 4 minus 2w squared plus 1. So, and don't worry that the answer is in terms of x, okay? We can put it back in terms of x at the end. So therefore, 7 w to the 4 minus 2w squared plus 1 minus 6, lots of 1 minus w squared. Just replace x to the 4 and x squared by these terms in terms of w, plus 1 equals 0. So 7 w to the 4 minus 14w squared plus 7 minus 6 plus 6w squared plus 1 equals 0, which means 7w to the 4 minus 8w squared. Then I've got a plus 7 plus 1, that's 8, minus 6, that's plus 2, is equal to 0, which gives us the answer of B. Pretty neat.